Welcome to Module 1, Topic A, Lesson 4, continuing in our ratios and proportional relationships study. And this Lesson 4 is again kind of follows Lesson 3 in trying to identify proportional and non-proportional relationships in tables. Okay, I'm going to have you, just going to read through this problem with you and then have you stop or just pause this recording and then go on and complete the table yourself, and you'll see that there are questions that follow, A, B, C, D, E, F, G. Okay, so I would like you to go ahead and do that and come back, and I'll walk through them with you. Okay, so you take some time to do that and to see how well you're learning this material. So I'll go ahead and read it here. The example is, which team will win the race? You have decided to walk in a long distance race. Very interesting thing to do. There are two teams that you can join. Team A walks at a constant rate of 2.5 miles per hour. Team B walks 4 miles the first hour and then 2 miles per hour after that. And now your task is to create a table for each team, showing the distances that would be walked for times of 1, 2, 3, 4, 5, and 6 hours. Okay, so go ahead and you'll do that, and then using those tables, answer those questions that follow A through G. Okay, so pause now, and I'll be back. Okay, we're back. Let's go ahead and hopefully you had some success with this, and let's go ahead and we'll fill out these charts here together. Let me pull up my project I had going for this here, and okay, so here we go. So let's go ahead and just fill in this this table here. Get a nice image of this table where we could actually fill it in. Okay, so we know that Team A, and again let's go back there and look at that key word here. Team A had a constant rate, okay, and once you see that idea of constant, hopefully you know that that is the proportional one. So kind of answered that question A right away. But let's go ahead and look at that. So if we go ahead and look at A, 1, 2, 3, 4, 5, 6, all we do is multiply by 2.5 to get the distance in miles, okay, and that's just going to just keep changing like that. 10, 12.5, and then 15 at the 6 hour mark, 15 miles. Okay. Team B, a little bit different because again, to answer, go ahead and answer B. Yeah, B was as they started out the first hour 4 miles, but then they just picked up 2 miles every hour thereafter. So that changed a bit. Okay, and it made this entire table non-proportional, okay, because you have 4 miles here at 1 hour, so that's a multiplier of 4. But then if we were to look at 2 to 6, that was a multiplier of 3, and again it's going to change as you move move down the chart. But with A, you could predict always at a certain time how many miles they would go, okay, if they're going to walk such a consistent rate, which has got to be a very difficult thing to do. All right, so answering question A there, for which team is distance proportional to time, that would be A, and if you were going to explain your reasoning, you would just say that for every time there equals actually we would say distance. Let's just go ahead and just change this a little bit, because we could just say, you know, distance equals time times 2.5, okay, or in this case 2.5 t. Okay, we could say it like that. Distance equals 2.5 t, and this is consistent. Okay, so therefore it is proportional. Okay, Team A. Now, if we were to say, now we want to know, well, explain how you know the distance for the other team is not proportional to time. Well, you just have to look at it. And as we had said before, right here we have a multiplier of 4 that way. So we couldn't, in this case, we couldn't do, D equals some value of t here, okay? Some value of t. But the first hour, it's 4t, okay? 4t. Distance equals 4t, but then over here it's distance equals 3t, okay, and that's over here at hour 2. All right, so these are not consistent, okay, therefore it is not is not consistent. Okay, question C asks, at what distance in the race would it be better to be on team B than team A? So if we go ahead and just look back at the chart we did here, you can see Team B is ahead of Team A after hour 1 or 4 miles. Okay, hour 2, 6 miles. They're still ahead. Okay, they're still gone ahead, and then you have hour 3. They're at 8 miles and still ahead there. But then we see at 10 miles, if the race were 10 miles, they would tie at 4 hours each, okay? But all those other races here, for a 4-mile race, 6-mile race, and a 8-mile race, they would a B would win. So those would be better for B. Okay, and D asks you, if the members on each team ran for 10 hours, how far would each member run on each team? So we have to go ahead and look at 10 hours. If we were to go ahead and here, let's just get this out of the way. Let's just extend this chart right here. Okay, so if we go ahead and do that, let's extend this chart. Okay, I'm just going to go through all that right there. We want to go up to, they said 10 hours, right? Easy here though, right? 7, 8. We don't really even need to go through this too much fuss here, because we know this is going to be 25. Because of our constant rate, we know that all we have to do is multiply time, okay, by times 2.5. Okay, that's all we have to do to get that. So 25 miles in 10 hours. I think I am actually, hold on a second, I need to, if the members ran for 10 hours, okay, yes, that's right, 10 hours, good. All right, 25 miles. Sorry, I'm getting mixed up between miles and time. Maybe you did the same, I don't know, this is driving me crazy here, so hold on a second. Okay, all right, so if we extend this out, a little bit different, we can't apply any formula like t times 2.5, but we can, it's not that hard, at 10 hours there, we're just adding 2 now, 18, 20, and 22. Okay, what does this question ask us again? The members of how far, okay, all right, so A would run, as we can see here, they are running 25 miles, okay, and then the people on B are running 22 miles. Okay, so A equals 25 miles, and then B equals 22 miles. Okay. So E asks, will there always be a winning team no matter what the length of the course? So if we go back again, we notice that at 10 miles, I'd highlighted it already, at 10 miles there would be a tie. They would both have run 4 hours. But that seems to me to be the only time that would happen, and especially considering that that B is getting further and further behind as you move up in the hours. As you can see, it's they were only a mile behind here, and now by 10 hours they're now 3 miles behind. So they're losing ground. So it seems to be that this would be the only place where there would be no winner. Okay. See, F asks, if the race is 12 miles long, which team should you choose to be on if you wish to win? Yes, indeed, if you wish to win. Okay, and why would you choose this team? Okay, so anyway, let's go back and let's look at, we're looking at 12 miles. Okay, So now 12 miles for, let's see here, 12 miles right here. 12 miles for team B is 5. They would have been running 5 hours. Okay. Now for A, we can't actually see, 12 doesn't appear on our chart. Okay. But we can see that we can see right here that 12 is at 12.5 miles they've run for 5 hours. Okay, so they've actually run more. They've run a further distance in 5 hours than B did in 5 hours here. Okay, so we have to assume, okay, that at 12 miles, okay, we're going to be moving this way, so it's going to be less than 5 hours. So we'd probably want to be, if we wanted to win, we'd be on team A. Now we can apply the formula, okay, because if distance equals t times 2.5, this is for A, for team A over here, okay. We could apply that, distance equals time, but now we know distance. So if we did the distance as 12 equals t times 2.5, then all we would have to do then is to divide 12 by 2.5. Okay. Okay. So if we are going to, I'm going to go back here. I just lost something, so I got to find my recording again here. So bear with me. We were applying the formula. Okay, we're applying the formula here. So we wanted to do. We said we knew 12. This is for team A again. 12 equals that was the distance, and so we had time by 2.5. So if we went ahead and did that, let's actually, we could just go ahead and do this. We could do 12 divided by 2.5. And so we know that that's going to be 5 there, right? And that is what, 11.5? 12.5. So we already know that's 12.5, so it's less than 5. Okay, so now we know it's 4, and we're pretty good with that, aren't we? We're just going to say that's 4, and that's 10. Okay, blah blah blah, and da 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 da. What's that? 0.8. Okay, so again, you can see we have 4.8 hours for 12 miles for team A. Okay, but again, we could just look at the table and we can tell by what we had said right here. We already know at 5 hours they've gone 12.5 miles. Therefore, 12 miles would have taken less time. Okay. All right, that was E. No, actually, that was F. Okay, so F we would have wanted to be on team A. Okay, and why would you choose that team? Kind of explained it there. Hopefully, you guys had something similar. And let's see, how much sooner would you finish on that team compared to the other team? And if we went ahead and went back, we would see we got 4.8 here. So it looks like we got 4.8, and so you'd finish 0.2 or 2/10 of an hour, which is 12 minutes, right? 2/10 of an hour or 12 minutes. Okay, 2/10 of an hour or 12 minutes, and see if you guys do understand that, how that works out. 2/10 of an hour, so 1/10 of an hour is 6 minutes. Okay, if you split up 60 minutes into tenths, okay, there's 6 in each one, right? So yeah, so 12 minutes. You'd be at 12 minutes faster. Okay. Okay, so on my sheet here, I have a different set of student materials. There are some exercises which are really very interesting to do, but I think I'll leave those for classroom time because you don't have them in your booklet, in your binder. So go ahead and do the problem set and the exit ticket for this lesson 4. Okay, and yeah, and come back soon for lesson 5.